So today we're going to talk about solving polynomials by factoring. The first way that we're going to use to solve polynomials by factoring is the sum and difference of cubes. This method works when you have a perfect cube for both terms. So for this section, we're going to need to start recognizing some basic cubes. For instance, 0 cubed is 0 times 0 times 0, or 0. By that same logic, 1 cubed is 1 times 1 times 1, which is 1. Now, when we start to get to 2, we have to go, well, 2 times 2 is 4. Times 2 is 8. 3 cubed is 27. 4 cubed, 64. 5 cubed, 125, and so on. Now, the other thing that we have to remember on cubes is, unlike with squared, where negative 2 squared is the same as positive 2 squared, a negative that's cubed will still be negative, because, for instance, negative 2 cubed is negative 2 times negative 2, which is positive 4. But then positive 4 times negative 2 brings us back to negative 8. So, here are our formulas for sum and difference of cubes. We will be using them throughout today. So, if I say a cubed plus b cubed, so for instance, x cubed plus 27, I first have to cube root both sides. X cubed would just become x, and b cubed, being 27, means b would be 3. So we would say a plus 3 times a squared minus ab plus b squared. And we'll see what all that means once we get to it. Now, if we have the difference of cubes, that means a cubed minus b cubed. So something like x cubed minus 27. And the big thing to note here is the differences that we really should notice here is if we have sum of cubes, we end up saying a plus b times a squared minus ab. Whereas on difference, it's a minus b, and then we say a squared plus ab. So let's try a couple of these to get an idea. One more quick thing. Whenever we are solving them, we're going to need to use a formula that we've used a few times before, and that is the quadratic formula. So whenever we're using sum or difference of cubes to find our solutions, we're also going to need to use this formula. So I'm bringing it back up here so that we can recognize it when we see it later. Negative b plus or minus the square root of b squared minus 4ac. Remember, that part, by the way, is called the discriminant. That's very important for us to remember, because I always recommend that we deal with the discriminant first. All divided by 2 times a. Alright, so here's our first example. It's going to say x cubed plus 64. So, and that all equals 0. So our first step is we have to figure out what our a value is. So the cube root of x cubed is just going to be x. Now our b value is going to be the cube root of 64. And if you were listening earlier, one of the cubes I recommend you know is that the cube root of 64 is not 8, like some of you might be thinking. That's the square root. But instead it is 4. So now that we have our values, we can start plugging them into the formula. So remember, the first part of our formula is that we say a plus b. So in this case it would be x plus 4. Then the second part of our formula is to write the other part, which is a squared, so in this case x squared, minus a times b. So x times 4 I would write as 4x. And then plus b squared. 4 squared is 16. So that is our new version of the factored different sum of cubes. So now that we've done that, we can already find one of our answers. In this case, one of our solutions, x plus 4 equals 0, means x will have to equal negative 4. See, we're a third of the way done. That means this question is super easy. But now for the other part, we do actually have to use the quadratic formula. So for this part, we're going to need a new a, b, and c. For just this trinomial, remember a is now our coefficients. So a would be 1 for x squared, because that's 1x squared. B goes with the minus 4x, so b is negative 4. And c is 16. So, as we write out this equation, the first thing I need to do is I need to start writing out the quadratic formula. So let's see, negative b, well, since b is negative 4, the negative of a negative 4 is 4, plus or minus. Now I need to deal with the discriminant. So the discriminant, for those of you that have forgotten, is b squared minus 4ac. So let's see, b squared, negative 4 squared is 16, minus 4 times 1 times 16. Well, let's see, that means it's 16 minus 64, or negative 48. So now I need to square root negative 48. Well, I already know that square root of negative 48 is square root of negative 1 times positive 48. And the square root of negative 1 is I. And then 48, I actually know because I know that it was just 16 less than 4 times 16. That means I know that this is going to be the square root of 16 times the square root of 3. Or, in this case, how we're actually going to write it, as 4 plus or minus 4i square roots of 3. All over 2 times 1, which is 2. So you might be going, are we done, Mr. Peacock? And we almost are. The only thing that we have to do to make this complete is we have to make sure that there aren't any common factors we can pull from both the numerator and the denominator. And since both parts of the numerator are multiples of 4, and our denominator is 2, we can divide everything by 2, meaning 4 becomes 2, plus or minus 4i square roots of 3 becomes 2i square roots of 3. And those are our other two answers. So let's try another problem. You might have seen this earlier when I accidentally went to the next slide a little early. So here we go. X cubed minus 27. Oh, that's interesting. This looks very familiar. It's almost like I was using 27 earlier. And when I mentioned 27 earlier, you might remember, first off, a would be x, but b, the cube root of 27, is going to be 3. So, since we're talking now about a difference of cubes, because it's x cubed minus 27, I'm going to end up saying x minus 3 times x squared minus, let's see, 3 times x is 3x, plus 9. Sorry, and that's plus. Remember, it goes a minus b times x squared plus ab. Sorry, a squared plus ab. So this is our formula. So the first part we're going to want to do is find our solution for x minus 3, because that part's easy. It just means that x equals 3. But then we have to find the other solution. So b squared minus 4ac. All right, so first we find our a. A is 1. B is 3. C is 9. So negative b. B is 3, so that's negative 3. Plus or minus. Now I'm going to go find that discriminant. So this becomes b squared, so 9 minus 4 times 1 times 9. So that would be 9 minus 36, or negative 27. So let's see, the square root of negative 27, well, I already know that that is square root of negative 1, which is I, times the square root of 9 times the square root of 3. So this becomes 3, and this stays square root of 3. So this becomes negative 3 plus or minus 3i square roots of 3 all over, since a is 1, that means all over 2. So can I simplify this at all? Well, let's see. 3 divided by 2 I can't simplify, so it looks like we actually already have our answer. So our other answer would be negative 3 plus or minus 3i square roots of 3 all over 2. And those are all of our zeros. So now let's try another. Okay, so now you'll notice we no longer have a leading coefficient of 1. I'm now saying 8x cubed minus 64 equals 0. So where before it was very easy to find our a value, because a was just x, I now have to say what is the cube root of 8, which in this case means that a is now 2x. And b, the cube root of 64, we've already said is 4. So now you'll notice this says minus 64, meaning this is a difference of cubes, not a sum of cubes, meaning 2x minus 4. Ooh, you know what I just realized? I can make this entire question way easier if I just factor this out a little first. 8 and 64 both happen to be numbers that I can very easily make smaller because they're both multiples of 8. Meaning if I divide everything by 8, it becomes x cubed minus 8 equals 0, which is a much easier solution. So a equals x now, much easier, and b equals the cube root of 8, we already said earlier when we thought it was a different problem, 2. So now that we know that, x minus 2, and then our other side, x squared plus 2x plus 4. Alright, so now we're going to use our quadratic equations. So a is 1, b is 2, c is 4. So this becomes negative 2 plus or minus, now let's find our discriminant. So that becomes 2 squared, or 4, minus 4 times 1 times 4, so that becomes 4 minus 16, or negative 12. So let's see, the square root of negative 12. Well, I already know the square root of negative 1, that's going to be I. That seems to be a common theme so far. And that's the square root of 4 times the square root of 3 to get our positive 12. The square root of 4 is 2, meaning, going back to our original equation, negative 2 plus or minus 2i square roots of 3 all over 2 times our a value of 1, meaning 2. So our final answer, because all of those are multiples of 2, is negative 1 plus or minus I square roots of 3. And because we forgot to do it earlier, the 0 for x minus 2 is just positive 2. So let's try one more of these difference of cubes or sum of cubes, and then we're going to move on to a new way that we can also solve these. So in this case, you'll notice it's a sum of cubes, but where we now have 27x cubed plus 1 equals 0. Now, I don't want to go into a mistake like last time and forget to find a greatest common factor. So I'm going to check real quick and make sure there aren't any. So let's see. 27 and 1. Well, since one of these numbers is 1, I know there's not a common factor in this case except for 1, so it's going to stay. So now let's talk about our a value. In this case, a is the cube root of 27x cubed. So the cube root of 27 is 3, and the cube root of x cubed is x. So our a value is 3x, And our b value, the cube root of 1, is in fact 1. So now let's start writing. 3x plus 1, because we're talking about sum of cubes, so it's a plus b, times a squared, so that is 9x squared, minus a times b, so minus 3x times 1 is 3x, and then plus 1 squared, meaning plus 1. So let's first start with our 0 on the part that's easier. 3x plus 1, well, let's see. If that all equaled 0, we'd subtract 1, so negative 1, and then divide by 3, so negative 1/3 would be one of our zeros. But now let's find our other one. So we're doing quadratic formula again. A is 9, B is negative 3, and C is 1. So I have negative of negative 3 is 3, plus or minus. Now I have to deal with this side. The square root of negative 3 squared is 9, minus 4 times a, which is 9, times c, which is 1. So this becomes 9 minus 36, which is negative 27. We've already done this before. Negative 20, the square root of negative 27 was 3i square roots of 3. And that's all going to be over 2 times a, which is 2 times 9, or 18. So there is a common factor between 3, 3, and 18, and that is the number 3. So I'm going to divide each part by that. So that's 1 plus or minus I square roots of 3 all over 18 divided by 3 is 6. And that is how we use the sum or difference of cubes. But this only works whenever it's written in this specific formula, where I have something x cubed plus a constant, or minus a constant. So what are some other ways that we can sometimes use to factor out cubic functions? Another way we can do is called grouping. Now you might recognize grouping from when we've used it in the past when talking about factoring quadratic equations. But when we group like this, we don't actually have to first separate out our squared or our x. We just have to deal with grouping our first two terms and our second two terms. Now, I'm going to make a quick point right here. You might notice in this equation right here, it says x cubed plus 3x squared minus 4x minus 12. But you'll notice how I grouped the minus sign in between 3x squared and 4x is in between parentheses. What that means is this minus is going to change everything I placed in this parentheses, which means the minus 12 becomes plus 12. It's important that we notice that, or else it's going to completely mess up our equation here. So, first part that we're going to factor out is x cubed minus plus 3x squared. So if you'll notice, both of them have x's. In fact, both of them have at least two x's. So our greatest common factor between those two is going to be x squared times, let's see, if I divide x cubed by x squared, I just get x. And then 3x squared divided by x squared is 3. So now what we have in our parentheses is x plus 3. Now let's talk about our second section. So we're subtracting, and then what is our greatest common factor between 4x and 12? Well, they don't both have x's, so I can't pull out an x this time. But what I can pull out is the number 4, because 4 goes into both 4 and 12. So this becomes minus 4, and our grouping inside is just going to be 4x divided by 4 is x, plus 12 divided by 4 is 3. Now, let's check, just like we did with grouping before, are our parentheses the same? In this case, they are, which means that this grouped properly. If they are not, it means that either you did something wrong while grouping, or this equation cannot be done using grouping. Either is a possibility. So, in this case, That means our final grouped version of this factored out would be x squared minus 4 times x plus 3 is going to equal 0. So now that we've done that, our zeros are 3, and if you look, x squared minus 4 is difference of squares. Now I know some of you may be going, difference of squares? That sounds very similar to the terrifying difference of cubes that we just did. But what I'm going to remind you is the difference of squares is much easier. It means x squared minus 4 just becomes x plus 2 times x minus 2. Meaning our final answers are going to just be negative 2, positive 2, and in this case, from our other factor, positive 3. Let's try another. So we're going to group again. X cubed minus 2x squared plus 2x minus 4. So I just grouped the first two equations and then the second two equations. Alright, my greatest common factor between x cubed and 2x squared is going to just be x squared. So that becomes x squared times x minus 2. And then our next part, our greatest common factor between 2x and negative 4 is 2. So this becomes, let's see, x minus 2. So my big question once again is, are the parentheses the same? And they are. So it's going to be x squared plus 2 times x minus 2. And that is all going to equal 0. So to find the 0 for x minus 2, it's just going to be 2. That part's easy, and I know we can all do that. But now we need to find the 0 for x squared plus 2. Now, you might go, doesn't that look like one of those difference of squares things? But it's actually the sum of squares. And while the rule ends up actually being very similar, we haven't really learned it yet. So I'm going to show you how this one works, and then we'll talk about how we can just use that in the future. So I would normally just say x squared plus 2 equals 0 because I'm trying to find my zeros. So my first step would always be subtracting 2 from both sides, which means x squared would equal negative 2. And if I wanted to get x by itself, I would have to square root. But, oh no, we're square rooting a negative, meaning x would equal I square roots of 2. But because the square root can be positive or negative, we would say plus or minus I square roots of 2. Meaning, my solution over there is plus or minus I square roots of 2. So those are my three solutions for this equation. Okay, let's try this one right here. Grouping the first two and the second two. So 2x cubed plus 2x squared plus 6x plus 3 equals 0. So our greatest common factor between 2x cubed and x squared is x squared. So that becomes x squared times 2x plus 1. And then let's see the next part. Greatest common factor between 6x and 3 is 3. And that becomes times 2x plus 1 as well. So once again I check, and sure enough, my parentheses are the same. That means that this is working out just how it should. And that all equals 0. So x squared plus 3 times 2x plus 1. So my greatest common, my zeros are, with 2x plus 1, negative 1 over 2. And then with the x plus 3, remember it ends up having to be a net square root of a negative, so I. And then the square root of 3 is just square roots of 3. Plus or minus I square roots of 3. And those would be our answers there. So now let's do one more example of grouping, and then we'll go on to our next. So 6x cubed plus minus 8x squared minus 9x plus 12 equals 0. So I'm going to put my parentheses around the first two and around the second, But I'm noticing that in between 8x squared and 9x, I have a wonderful little minus mark, meaning that this plus sign becomes a minus sign. There we are. So, greatest common factor between 6x cubed and 8x is going to end up just being, well, let's see. 6 is 3 times 2, but 8 does not go into 3, but 3 doesn't go into 8, so it has to be 2. So 2, and then x cubed and x squared means x squared times, in this case, this is going to be 3x minus 4. And then we have our second part. It's going to be minus greatest common factor between 9x and 12. Well, let's see. 12 is 6 times 2, but neither of those are multiples of 6, and only one of those is a multiple of 2. So it could also be 3 times 4. Only one of those is a multiple of 4, but they are both multiples of 3, meaning that our greatest common factor in this case is 3. So that becomes 3 times 3x minus 4. And sure enough, if you look, like always, there we go. Hooray! The parentheses are the same. So all of this equals 0, of course. So our final factors would be 2x squared minus 3 times 3x minus 4. So our easy one right here is going to be the 3x minus 4. So that becomes 4 over 3. But to find the other one, 2x squared minus 3 equals 0. That means 2x squared equals 3. That means x squared equals 3 halves square root. So this will be plus or minus the square root of 3 over 2. So now what we're going to do is the easiest method of factoring in terms of what we've done, because we've done this before. And that is whenever we factor by finding a greatest common factor and then just seeing if we can factor the other part that'll just be a quadratic trinomial. So let's see, our first part says x cubed plus 3x squared minus 4x. We have a common factor of x. This becomes x times x squared plus 3x minus 4. And that is all going to equal 0. So we already have one of our zeros. The 0 for x is just 0. Now let's see. What are two numbers that multiply to be 4 and have a difference of 3? So that is going to end up being, let's see, 1 and 4, I believe, would be those. And because we have to add up to a total of positive 3, that means that the negative goes with 1. So that factor would become x minus 1 times x plus 4, meaning our final zeros are 0, 1, and negative 4. All right, let's try this one. So our greatest common factors, let's see, greatest common factor, all three of these actually have multiples of 2 and of x. So this becomes 2x times x squared minus 3x plus 2. So let's see, what are two numbers that multiply to be 2? Just 1 and 2, and sure enough, they do add up to 3. So this is going to be x minus 1, so we can get negative 3 times x minus 2. So our zeros are 0. Let's see, positive 1 and positive 2. All right, so greatest common factor in this case, all of these are multiples of 2, so 2x times x squared minus 4x plus 7 equals 0. So let's see. One of our zeros is definitely still 0 because 2x is 0 whenever x equals 0. But now let's see. Multiples of 7 that also add up to be 4. Let's see. 1 and 7. There are none, which means I guess we're done. Or we could always use the quadratic formula. I was pausing because I'm sure all of you erupted in cheers. So, here we go. Negative b, a is 1, b is negative 4, c is 7. So, negative b becomes positive 4 plus or minus. All right. Our discriminant is 16 minus, let's see, 1 times 7, 4 times 1 times 7 is going to be 28, so negative 12. 12 is 3 times 4, so that becomes and negative 1 is I. So this becomes 2i square roots of 3 all over 2. Since these are all multiples of 2, it becomes 2 plus or minus I square roots of 3 all over, well, all over nothing because we just eliminated that 2. So those are our 3 answers. Okay, so now that we've factored and solved cubic functions, we also can solve quartic functions. Quick reminder about what quartic means. It means where our highest term is going to be x to the 4th instead of x cubed, that use the quadratic pattern by factoring. So let's look at what the quadratic pattern looks like to remind ourselves. In this case, this is the quadratic pattern. X squared, then x, then 12. So the quadratic pattern in quartic form looks like this. So pretty much the same, only now everywhere we had an x, it's an x squared. So x is now x squared, and x squared is now double that, or x to the 4th plus 12. So instead of going 2, 1, 0, it's now 4, 2, 0. So now here's how we'd solve. Exactly like the other one. So originally, whenever it was saying x squared, we would have just said, well, what are our multiples of 12? And in this case, our multiples of 12 are 1 and 12, 2 and 6, and 3 and 4. And so we have to ask ourselves, which of these multiples end up adding up to be 8, or in this case, negative 8, and that's 2 and 6. So both of these would be negative. Now, while it still works, I'm going to actually use one of our formulas to factor just to show you how this works. In this case, I'll use box method. So let's see. X to the 4th, 12, negative 2x squared. Oh, I didn't write to the 4th. I wrote squared. Negative 2x squared and negative 6x squared. So let's see. Greatest common factor between x to the 4th and negative 6x squared is x squared. Negative 2x squared and negative 12 is negative 2. And that's it. Now let's try our other one. Ooh, let's not use the same color as earlier. X to the 4th and negative 2 is x squared. Negative 6x squared and 12 is negative 6. So our final factored version would be x squared minus 6 times x squared minus 2, which, by the way, means the way that we have been simply factoring out these quadratic equations whenever the leading coefficient is 1 also works on these specific types of quartic equations. So x squared minus 6 and x squared minus 2. So in both of these, unfortunately, it ends up being plus or minus the square root of 6 and plus or minus the square root of 2 when we use difference of squares. Let's try another. 2x to the 4th plus 9x squared minus 5. So because first, are there any common factors? 2, 9, and 5? Nope. So I multiply my leading coefficient by my constant, which gets me 10. In this case, it's a negative 10, which means I'm looking for two numbers that have a difference of, in this case, positive 9. So let's see. 1 and 10, 2 and 5. Well, the only one of those with a difference of 9 happens to be 1 and 10. So 1 and 10, the negative has to be the smaller number, so negative 1. So now I'm going to use, let's do grouping this time just for funsies. 2x to the 4th minus x squared plus 10x squared. Notice these two combined become 9x squared, and then minus 5. Grouped. Greatest common factor between 2x to the 4th and x squared is x squared times, in this case, 2x minus 1. And then greatest common factor between 10x squared and 5, 2x squared minus 1. Greatest common factor between 10x squared and negative 5 is going to be 5. And that is going to be 2x squared minus 1 as well. So x squared plus 5 times 2x squared minus 1. That means this is plus or minus the square root of 1/2. And my purple part becomes I square roots of 5, and that is plus or minus. For a reminder as to why those work, look at earlier examples where I did that part. All right, here's our last one of these. X to the 4th plus 8x squared minus 9. So let's see, my factors of 9. In this case, we have 1 and 9 and 3 and 3. Do either of these have a difference of 8? 1 and 9 do, meaning negative 1. So as I pointed out earlier, x squared minus 1 times x plus 9. X squared plus 9. So this just becomes 1 and negative 1. And then this becomes, unfortunately, 3i and negative 3i whenever we factor them out. Oh, looks like we had an extra one that I had forgotten all about. So we're going to go into here. Two numbers that multiply to be 3 times 6 is 18. 1 and 18. 2 and 9. 3 and 6. Do any of those add up to 11? Oh, it appears 2 and 9 do. So 3x to the 4th, negative 2, x squared, negative 9x squared, and 6. Finishing up my box for visuals. Now let's look at, let's redo that box, make it look a little bit nicer. Now, greatest common factor between 3x to the 4th and 9x squared. That's going to be 3x squared. Negative 2x squared and 6 is negative 2. 3x to the 4th and negative 2x squared is just going to be x squared. Negative 9 and 6, I'm going to say, is negative 3. So x squared minus 3 times 3x squared minus 2. So, because these are both minus, it becomes the square root of 2/3 for the purple part, and the other one, plus or minus the square root of 2/3, and plus or minus the square root of 3. All right. Now we're going to do these just to make sure that we understand. Solve each equation by using one of the other factoring methods in the other examples, and remember to look for the greatest common factor. So greatest common factor between 2x to the fourth and 18x cubed. Well, there appears to be at least an x to the cubed, and 2 and 18 both have a common factor of 2. So this becomes 2x to the 2x cubed times x plus 9. Meaning our two zeros are 0 and -9. Simple. Let's try this one. Oh, well, this one looks a little harder because it says x cubed equals 4x squared plus 12x. So I have to move certain things over. In this case, I'm going to move both of these so that my leading coefficient stays positive. X cubed minus 4x squared plus 12x. Sorry, not plus, minus 12x is going to equal 0. So greatest common factor is x. This becomes x squared minus 4x minus 12 equals 0. So my first factor is 0. Now I'm going to factor out this. Two numbers that multiply to be 12 and have a difference of 4. 1 and 12, 2 and 6, 3 and 4. Well, it looks like in this case 2 and 6. And the 6 has to be the negative because we're going to end up getting -4. So that becomes x plus 2. You know what? Let's write that in red so that it looks a little different. X plus 2 times x minus 6. So our other two answers are -2 and +6. All right, we are now to our favorite types of problems in the entire world, the types of problems that mix numbers and words. I would like to call them, and I'm just making this up here, word problems. Copyright me. Anytime anyone uses it, they have to pay me like $1. I already sent it in the mail before I published this video. So, sketch a diagram that represents a rectangular piece of cardboard that measures 14 inches by 18 inches. So I'm going to sketch that right now. Here we go. Oh, look at this perfect looking cardboard. It's like I just took a picture. So 14 by 18. I've also perfectly drawn this to an exact scale. Now, by cutting 4 squares from the corners of the rectangles of lengths of x, so basically what I'm doing is this, and I don't know how long these are, but I do know that they're all squares and that they all are cut by the same amount, being x. Now you might be wondering, why would I do that? Basically, I can form a box, or I would honestly rather say I can form a lid, because basically when I do that, it'll end up looking like this. It'll look like that once I pull it out. Now, the longer I cut, the higher up this part becomes, the larger x is. But the smaller left over we have on the sides. So we get a smaller tray with longer sides, the longer x is. So the function v of x equals x cubed minus 6x squared. Ooh, this looks gross. I needed to change this. X cubed minus 16x squared plus 63x models the different volumes with respect to the different values of x. So our first question is, for the function v of x, what are the x-intercepts? And what do they mean? So to find that out, I'm going to go in and plug those in. So Our greatest common factor between the three is x, and it becomes x squared minus 16x plus 63. So I need to factor out 63. Let's see. I know that 1 and 63, 3 and 21, and then 7 and 9 are my factors. Which of those add up to be 16, 7, and 9? Meaning x minus 7 times x minus 9. So my zeros in this case would be 0, which would represent me not cutting anything off the side, because x is the length of the side. If I had 0, it's where I cut nothing, because I can't cut a negative amount and make them longer. Then I have x minus 7 is 7. Now the reason why 7 would be there is if the length of 7 was there on each side. Well, let's see, since this side right here is 14, I would basically have eliminated an entire edge. So I can't actually cut all the way to 7, or that side's wrong. Or finally, x minus 9 would be 9. That goes with the 18. I would do the exact same thing on the other side if I cut 9. I also can't cut 9 because then I would have like overlapped by 4 inches on my 14 sides. So now that we have those, or actually, yeah, by 4 inches. So the 0 represented in this case the least I could do. The 7 represented the most I could do on the sides of 14, and the 9 the most I could do on the sides of 18. So our final question in this case is, and you know what, let's eliminate these three. So they were once again 0, 7, and 9. Which of the following would represent a reasonable domain for the volume of the box as a function of x? Of the height x is expressed by the v of x shown in part A. So in this case, I know that the least it can be is slightly greater than 0. It can't be 0 because then I haven't actually cut, which I said I did. So I'm going to put 0, but I'm going to put a parenthesis mark there because it can't be 0. Now, the most I can do is either 7 or 9, but the problem is I can't get to 9 because I've already passed 7. So the most I could do is 7, but if I actually did 7, I've eliminated an entire side, which actually means I can't create the box. So that means I have to be at least slightly less than 7 in order to do that. So 0 to 7, but those are not included. And that is how we would write this equation. And that's it for this video. I hope you've found it instructive. I know this one was a little longer, and there you go. Have a good day, everybody. Goodbye.